bucka. Ha. You know the deal.
The next thing we're going to talk about is an introduction to algebra. And the first question you're probably going to ask yourself is, well, why do we even need algebra? And algebra is used for a variety of purposes, but when we're first learning about algebra, one of the main reasons we need it is in order to translate English sentences into math sentences. And we're going to take a look at a couple of examples of what I mean by that. So the first example we're going to look at is suppose you get a job, and most of the time the first job you get paid by the hour. And let's suppose that in that job you get paid $10 per hour. So to calculate how much money you make, the only piece of information you need to know is how many hours did you work. And once you know how many hours you work, you're able to answer the question, well, how much total pay did you get? So suppose we worked for 5 hours. So that would answer the question, how many hours? Well, in order to figure out how much the total pay is, we need to calculate that, and we would multiply 10 times 5, because we get paid $10 per hour for each hour. We're working for 5 hours, and that's going to tell us that our total pay is $50. Well, we don't necessarily have to work 5 hours. Suppose on another shift or during another day, we worked 8 hours. So to calculate total pay, again, we get paid $10 per hour. So we would multiply 10 times the number of hours, which in this case is 8. And we know that we made $80 for that shift. Well, let's say you want to calculate how much you made in a week. Each of these examples, 5 hours, 8 hours, that's probably how much you're working in a day. But suppose after a week you worked 36 hours. Well, once again, to calculate what our total pay is, we have to multiply 10 times the number of hours, and in this case it's 36 hours for the week. So our total pay for that week is $360. So what we're seeing here is that there's a couple of pieces of information in this situation that change or vary. The number of hours that we work changes or varies, and the total pay changes or varies. So if we want to write a math sentence that expresses how much money we make for any number of hours, we might start by writing out, well, how do we calculate that? And we can write that out just as an English sentence, which would look a little something like this. So to calculate our total pay is 10 times the number of hours, and we've seen a few examples of that. Well, now what we want to do is we want to translate this English sentence into a math sentence. When you have a simple sentence that you want to translate, like if you say 4 plus 3, that's pretty straightforward. You're just writing numbers and symbols, and that's all we have in a math sentence is numbers and symbols. So if we look at this math sentence right away, we can see if we start with total pay. Well, I don't have a direct way to translate that into a math sentence. So I'm going to leave that blank for now. Similarly, the number of hours we have, I don't have a way to directly translate that into a math sentence. So this is where algebra comes in. This is where we need to use algebra. Each of these pieces of information varies or changes. So if we want to write those values in a math sentence, we can't just write them as a number because they can be different. So this is where we have to use what's called a variable. And a variable is just a letter or a symbol that represents a number. And it usually represents a number that can change in a situation, that can vary in a situation. So in this situation, we actually have two pieces of information that can vary. Our total pay can be different, and the number of hours can be different. So we're going to write a math sentence using variables for each one of those pieces of information. So usually when we're translating a math sentence from English to math, usually we can just directly translate it. But what we have here is a situation where we have to use some variables. So we're going to start with total pay, because that piece of information can change. And what we're going to do is assign a variable to that. And in order to do that, we have to explain how we're translating. So when we explain how we're translating, we use what's called a let statement. So we might say something like this: let y represent the total pay. Now I just randomly selected y. We could have chosen p, because total pay starts with p. We could have chosen a symbol like smiley face. In algebra, we're using variables which are any letters or symbols. So I just randomly selected y to represent total pay. And similarly, I'm going to represent a variable to represent the number of hours. Now, because total pay can be different from the number of hours, and as we saw in all the examples that we saw, it was different from the number of hours, we actually have to use a different variable. If we use the same variable for number of hours, that would mean that it's always the same, the total pay. So if we worked 1 hour, our total pay is $1. If we worked 3 hours, our total pay is $3. That's not the case here. So we have to use a different variable to represent the number of hours. And that's our other piece of variable information here, the other piece of information that changes. So our let statement for number of hours, and again, I've just randomly selected this letter. I've chosen X to represent the number of hours, and it has to be a different letter from the total pay. Well, now that we have variables to represent these pieces of information that change in this situation, I can now go about translating this math sentence. So if we start with total pay, well, if I want to write that in a math sentence, I can only use symbols and operations. So we've said let y represent total pay. So instead of total pay in a math sentence, we're going to write y. Next we have the word is. Is in a math sentence is usually written as equals. And now we have 10 times the number of hours. Well, if I start with 10, to translate that in a math sentence, I can simply write the number 10. Times is usually written using this symbol. And then I have number of hours, which again, it varies, it changes, so I have assigned a variable to that, and we've called that X. So here we have total pay is 10 times the number of hours, where Y represents the total pay and X represents the number of hours. Now if you look at this math sentence, right away you probably recognize, well, this part of the math sentence looks a little bit confusing because we've used this symbol X for times, which we usually do. Usually when we write multiplication, we write an X. We've also used the letter X as a variable. Because the letter X is very often used as a variable in algebra, we try to avoid using this symbol for multiplication. So instead of writing 10 times x as 10xx, to multiply 10 times x, we just put the number next to the letter. When we see a number next to a variable like this, it means we're multiplying 10 times x. So there's our first example of translating an English sentence into a math sentence using algebra, because we have a couple of pieces of information that vary here. So here's another example of a situation where we have a couple of pieces of information that vary, and there is a mathematical relationship here. So we have the total cost of a taxi ride, and usually when you're in a cab or a taxi, when you get into the cab, you start off with an initial fee. An initial fee is just an amount that it starts at. So when the cab driver turns the machine on to calculate the fare, it usually starts at a certain amount that's not zero. So in this case, the initial fee is $3. So your cab ride starts at $3, and then after that, you're charged $2 per kilometer. So if we want to simplify this and just write this as a sentence in terms of how we calculate the total cost, we would probably write something like this, where we calculate the total cost by multiplying 2 times the number of kilometers, and then we have to add 3 because our initial fee was $3. So for example, if we go, say, 5 kilometers in the taxi ride, we have to multiply 2 times 5 because we're charged $2 per kilometer, and then we have to add 3 because we started off with that $3. Following order of operations, we have to do multiplication first. So for the kilometers, we were charged $10 plus that initial fee of $3. Our total cost is $13. So if we go 5 kilometers, our total cost is $13. The thing with a cab ride is the number of kilometers can vary, it can change, and so can the total cost. So when I want to go about translating this English sentence into a math sentence, first off we look at this part and we see total cost, which varies, it does change. And I don't have a direct way to translate that into a math sentence, so we know we're going to have to use a variable to translate that part of the math sentence. The other piece of information that changes here is the number of kilometers. So again, I'm going to have to use a different variable because the number of kilometers is going to be different from the total cost. So when we're translating from an English sentence to a math sentence, and we've got some variables involved in that math sentence, we always start our translation with what's called our let statement, where we assign a variable or variables to the unknowns. So in this case, we'll start with the total cost. And again, I'll just use the same variables as the last example. So we'll say let y represent the total cost, and let x represent the number of kilometers. Well, now when I go about translating this, we'll start with total cost. Now we have a way to translate that because I've set let y represent the total cost in our math sentence. So our math sentence starts with y is, once again, is equals. And now we're going to be multiplying here. We have 2 times the number of kilometers. So as we talked about in the last example, I don't want to use that symbol x for times. X is represented by the number of kilometers. So it's 2 times the number of kilometers, or 2 times x, which we write as 2x. Plus, I have a mathematical symbol for that. And then 3 is just the number 3. So here we have the math sentence that says y equals 2x plus 3, but y represents the total cost and x represents the number of kilometers. So if we were going to translate that back into English, it would say the total cost is 2 times the number of kilometers plus 3. So there's two examples of where we need to use variables to translate English sentences into math sentences. So here's another example of where we have to translate an English sentence into a math sentence. And once again here we have a piece of information that can vary. So the first part of this sentence here, it just says a number. We don't know what the number is, so that number can be different. It can vary. So our first step here is to assign a variable to that piece of information. I'm going to say let W represent a number. Well, now that we've translated that part, we can go about translating the rest. Now, here we have divided. Usually for divided, we use this symbol. We don't use that symbol usually when we're dealing with algebra, though. The reasons for that will become more clear when we start to solve equations. Another way to write division, though, is as a fraction. And so when we want to divide a number divided by 2 as a fraction, that's a number over 2. So we have W over 2 is, translates to equals, and then 7, we have the symbol, the number 7. So now we've translated this English sentence into a math sentence using a variable for the piece of information that changes. So we're going to look at one last example here. Again, I've got an English sentence. Taylor's age increased by 2 is 12. The piece of information that can vary or that can change or that we don't know is Taylor's age. So the first thing we have to do is assign a variable to that unknown or to that piece of information that changes. And we're going to say let Taylor's age be T. Now that we have that, we can translate the entire sentence here. We start with Taylor's age, which, as I've translated, we're going to call that T. Increased by 2 means we're adding 2. So we can add 2. Adding and subtracting, we just use the symbols we've always used for adding and subtracting. And then is equals. And finally, the number 12. So now if we were to translate that back, T, which is Taylor's age, increased by 2, is 12. So to finish off our introduction to algebra, I'm going to ask you to translate a few English sentences here into math sentences. So for each one, the first step is going to be that let statement, where you assign a variable to the piece of information that you don't know or that can change. So for the first one, we have a number decreased by 8 is 4. Question number 2, Spencer's height, then divided by 2 is 2. And remember how we write division when we're dealing with a math sentence that involves algebra. For question number 3, we have total income from a dance is 5 times the number of students who attend, so each ticket costs $5. And finally, the area of a rectangle is 18. For the last one, what you're going to have to do is remember, how do you calculate the area of a rectangle? And I might suggest you write that as an English sentence first, and then try to translate that into a math sentence using variables for the pieces of information that can vary. If you're able to translate those English sentences into math sentences using algebra, congratulations, you now have a firm understanding of an introduction to algebra.